Now, we will enter the new chapter. Okay, this chapter is called redox reaction. So, very important thing that we actually need to know for redox reaction is going to be what is redox reaction at the first place. Okay, so what is redox reaction? Anyone can actually tell me what is a redox reaction? Christopher?
A reaction that has a reduction and oxidation.
Okay, so a reaction that has both reduction and oxidation. Okay, that's actually correct. So that's why it's going to be redox. Okay, redox. So reduction and oxidation is taking place. So of course, I think general thing, if let's say for example, if you have redox reaction, so we need to know what is reduction, we need to know what is oxidation. Now, for reduction and oxidation, so if I actually put it here, oxidation, and this is going to be reduction. So oxidation, we can actually define them. Okay, when you have increase in let's say you get oxygen. Okay, there is an additional oxygen suddenly appearing. Okay, additional oxygen suddenly appearing, that is called oxidation. If you have the oxygen is being lost, okay, that is called reduction. Example, if I have Fe is changing into FeO, so I can say that Fe has been oxidized into FeO. Okay, so Fe has received O, so it become FeO, iron oxide. Okay, so this is going to be example of oxidation. Reduction, I think quite simple. If you have FeO changing into Fe plus O2, for example. So this is going to be one example because FeO is losing the oxygen atom. So we can say FeO is being reduced. So this is going to be Fe is oxidized, FeO is reduced. Okay, please take note which one is being reduced. The one that I actually underlined over there. Okay, FeO is being reduced to become Fe. Okay, so that is going to be my first way to actually identify oxidation and reduction. That's first way. Second way is actually by looking at hydrogen. Okay, not so popular. I'm not going to actually look into that in detail also. If you lose hydrogen and if you get hydrogen, okay, it's going to be oxidation. If you lose hydrogen, that's going to be oxidation. If you gain hydrogen, that's going to be reduction. But since this is not something that I want to focus, I'm not going to actually go through it now. Okay, there's going to be third one, which is going to be very important, which is going to be known as oil rig. What is oil rig? Okay, oil rig is, okay, I think it's an abbreviation that we actually use. Okay, mnemonics that we use. Okay, so oxidation is loss. Loss of what? Loss of electron. Okay, so this is going to be loss of electron. Reduction is going to be gaining of electron. So you can see R I G O I L. Okay, you can actually remember this. Okay, this is going to be something, okay, that you need to remember. Okay, in terms of electron. Okay, in terms of electron. And then number four. Okay, number four we will actually learn later. Okay, something to do with oxidation number. Okay, this is going to be increase in oxidation number, gain in oxidation number. and reduction is going to be loss in oxidation number or reduction in oxidation number. That is going to be some definitions or how we determine something is going to be oxidized or reduced. Okay, I can give you some examples. Okay, let's say the example for number 3. Okay, I will put it under here, which is going to be, I wanted to actually discuss about half equation. Okay, so half equation normally we use, okay, to show, okay, the loss of electron or to show gain of electron. Okay, this is going to be half equation. I'll show you for one example. If I have Fe 2 plus, Fe 3 plus, and then copper 2 plus become copper. Okay, if I have this, okay, as in my equation, okay, if I have this equation, first question that I want to ask you, okay, first question that I want to ask you, is this a half equation? Ryan, do you think that this is going to be half equation?
I think no, sir.
Okay, why? Remember what I mentioned about just now, why we do half equation, to show what?
The charges
Charges, but there are charges here.
must be equal from left and right.
Okay. Anyway, the half equation is more Ryan is inaccurate actually. The half equation is generally yes, the charges must be equal left and right, but the important thing is actually you need to make sure that they have electron. Okay, they have electron, because that is actually going to balance the charges. But you cannot simply put the electron over here. Okay, this one. Okay, if you look at this this equation, this is like some equation, like for example, to be exact, okay, to be exact, this is called ionic equation. This is called ionic equation. From where I get ionic equation, probably if let's say I have Fe, maybe if I have iron sulfate, okay, iron sulfate reacting with copper hydroxide, it's going to give you Fe hydroxide plus copper over here. Okay, but this is going to be not the actual equation. I'll skip this part. Yeah, so basically, okay, basically what I wanted to show you over here is this is a combination. Okay, this is a combination of two half equation. Okay, this is a combination of two half equation. I'll write down the half equation for you. Okay, which is going to be, the first one is Fe2 plus is changing into Fe3 plus. Okay, now when Fe2 plus changing into Fe3 plus, Michael, can you tell me Fe2 plus is losing electron or gaining electron?
Losing electron.
Okay, they are losing electron. Okay, so normally losing electron we represent like this, but in chemistry when we write equations, we don't actually put minus electron. Okay, so something like your max, you have to bring this to the right hand side, where you are going to actually get it in this form, which is going to be, okay, it's not showing over there. Hold on, my internet connection not stable. I try to share the screen again. Okay, you have, okay, in chemistry what you need to do, okay, you need to actually bring the negative electron, the minus electron, to the right hand side, and you supposed to actually write down Fe2 plus gives you Fe3 plus plus electron. It's the same equation. Okay, it's the same equation. So what does it mean? Fe2 plus has lost electron. Okay, Fe2 plus has lost electron. Even, can you tell me now Fe2 plus is reduced or oxidized? Using oil rig. Even, can you hear me?
Yes.
Okay, even, can you tell me Fe2 plus in this particular equation, are they going to be reduced or oxidized?
Reduced.
Okay, why you say reduce?
Because it lose electron.
But I thought loss of electron is oxidized.
I don't losing charges, right?
No, you don't look at the charges. Okay, in this case, you see here, Fe2 plus has lost the electron to give you Fe3 plus. Okay, so if I say, okay, what happens to Fe2 plus? Fe2 plus has lost electron, therefore Fe2 plus is going to be reduced. Okay, oxidized here. Okay, it's going to be oxidized. They are going to be oxidized because it's going to be oil rate. Okay, oxidation is loss of electron to become Fe3 plus. Okay, this is using electron. Can even?
Yeah.
Now, I will erase this part now so that we don't actually get confused. Okay. Now, we have another equation here, Cu2 plus and Cu. Cu2 plus to become Cu. Now, how to change Cu2 plus to become Cu? Gaining of electron or losing of electron? Audrey?
Gaining.
Okay, you must gain. Okay, it's already lost 2 electrons, 2 plus, but now when I get 2 more electrons, okay, I am going to get copper. Okay, I'm going to form the neutral element. Okay, so that's going to be 2 electrons over there. Now here my question here is going to be the same. Cu2 plus to become Cu. Josh, are they going to be oxidized or reduced using electron? Cu2 plus has received 2 electron. Gain electron or lost electron?
That's reduced.
Okay, this is going to be gain of electrons, so that's going to be reduced. Okay, we are using this concept number 3. Okay, we are using this concept because it involves electron. Okay. Now, of course, since we are learning about half equation and this is ionic equation, I'll teach you this ionic equation is not complete. Okay, I will teach you why it's not complete. Okay, because when I write down Cu2 plus 2 electron to become Cu, Fe2 plus to become Fe3 plus electron. If you want to add both equations together, you must make sure the electrons cancel out when you add equation number 1 and equation number 2. If you look at equation number 1, they have 2 electrons. If you look at equation number 2, they have only 1 electron. Okay, so what you can do, you can actually times this by 2 so that you have 2 electrons. Whereby when you add equation 1 and 2 together, the both electron left and right will cancel out. Okay, so the idea is we want to cancel out the electrons. Okay, so when I add 1 and 2, what am I going to get? I'm going to get Cu2 plus 2 Fe2 plus to give you, okay, 2 electrons is gone, copper plus 2 Fe3 plus. So if I check again, is this a balanced equation? this is not a balanced ionic equation. A balanced ionic equation should be 2Fe2 plus and 2Fe3 plus. Okay, this is a balanced ionic equation. Okay, but again, to answer what Ryan actually said, okay, yes, now the charges are balanced. Okay, now the charges are balanced, but is this a half equation? The answer is no. Yeah, Ryan. So this is again is called ionic equation. The half equation is this and this. Okay, but please remember the tips to actually balance ionic equation is, okay, they must have the same charge left and right. So if you look at the charge, 2 times 2, 4, and then plus 2. So total charge is going to be plus 6. 2 times 3, that's going to be plus 6. No charge, Cu. So you can see plus 6 and plus 6. The charge are okay. So that is going to be the way that we write, okay? How to balance, okay? So do remember ionic equation, if you want to balance, please balance according to the half equation. Then you balance, okay? Now coming back, okay, to the last one, okay, which is the oxidation number. Okay, I will actually talk about oxidation number now. Okay, there are certain rules, okay, when it comes to oxidation numbers. Okay, what are the rules? Okay, any uncombined element, okay, any uncombined element, the oxidation number is going to be 0. Okay, these are the rules. Okay, any uncombined element, the oxidation number is 0. I'll give you one example. O2 is an uncombined element. Okay, it's an uncombined element. So they don't actually combine with Fe. Okay, they don't combine with other things. So O2, okay, is actually oxidation number is 0. The same thing if you have N2, oxidation number is 0. Cl2, oxidation number is 0. Let's actually look at Fe. It's an element. Okay, just element alone. Oxidation number is 0. Okay, what else? Okay, I'll give you more examples. If you have, for example, S8, sulfur molecule. Okay, not molecule, it's an element. Sorry. So S8 is a simple molecule. Okay, so still actually element. Okay, this one is going to be 0. Okay, please remember this. Uncombined element is 0. So if I want to actually look at this example here, if I have 2Fe2 plus Cu2 plus to give me 2Fe3 plus Cu. If I ask you what is going to be my oxidation number of copper, Sharon, what is my oxidation number of copper?
2.
0.
Oh.
Okay, please remember this. Okay, so this one is going to be copper is going to be 0 because it's element, uncombined element. Now the second one, okay, that I want you to remember, if you have group 1, okay, if you have group 1, okay, and then they are like for example in compound, okay, this one they are all in compound. Okay, if group 1 element is in compound, the oxidation number is going to follow the charge, +1. I'll give you some examples in a while. If let's say they are in a compound group 2, then they will follow +2. I'll give you one example. If you have a compound of, let's say, NaCl, okay, if I have NaCl, if I ask you what is the oxidation number of Na, okay, because Na is in group 1 and they are in compound, because they will form Na plus, okay, the oxidation number of Na, okay, is going to be, in this case, the oxidation number is going to be +1. Okay, Na in NaCl is +1. If I have MgCl2, if I want to find out what is the oxidation of Mg, then you just follow. This is going to be group 2. They will be Mg2 plus. They will tend to actually form Mg2 plus. Therefore, the oxidation number is +2. Okay. F generally, okay, in their compound, generally they are group 17, yeah, group 17. Generally, you can remember all group 17, generally they will follow -1. They follow the charge, but not all the time. Okay, not all the time. But for fluorine, yes, okay, they are always -1. The same thing, if you have Cl minus, okay, Cl and so on, tendency to form -1 is there. So I give you one example. NaF. If I want to know what is going to be oxidation number of F, it's going to be -1. Follow the rule. Now all hydrogen, okay, all hydrogen in compound, they will have +1, but I put it with an exception. Okay, not all the time. Okay, sometimes, okay, when you have compounds that actually have a metal and methyl hydride, we call it methyl hydride. Example, if you have NaH, they will not actually form +1, okay, because NaH, we will follow this one, group 1. So this one is going to be 1. So if I want to find the oxidation number of this, how to find? Okay, there is a method. You can put it as X. Okay, and then the overall charge, this entire charge is 0. So put equals to 0. And you will see X is going to be 0 minus 1 minus 1. So only in this NaH, H itself, the oxidation number is -1. Okay, some exceptions. Okay, some exceptions. But generally in other situations, for example, if you have H2O, oxidation number of this hydrogen is going to be +1. Other situations, they are always +1. I'll give you some other examples. NaHCO3. If I ask you what is the oxidation number of H over here, yes, it's still +1. Okay, similar to that, oxygen all the time is -2, but with exception of these two compounds over here. If it is in peroxide, H2O2, F2O, then the oxygen is not going to be following the order. Okay, I'll give you some example. Okay, how to calculate. If I want to calculate the oxidation number of O, hydrogen, I mentioned that all the time hydrogen is going to be +1 except NaH. Okay, so this one is +1, and then there's 2, so times 2, plus I want to find out what is the oxidation number of this. I put X, how many? There's 2. And then overall, what is going to be the charge? 0 equals to 0. I find out what is X. 2 plus 2x equals to 0, 2x equals to 2, x equals to 1. So it means now, in this particular situation, the oxygen is going to be +1 instead of -2. Okay, some exceptions. Yeah. If you have F2O, you can do the same thing. F, I told you, they are always -1. Okay, you can see always -1. 2 times -1 plus x, I want to know what is x, equals to the overall charge is 0. So x equals to +2. I bring over there. So here you can see the oxygen now is no longer -2, is going to be +2. So only for two conditions, they are going to be +2. +2 and +1. Most of the time, they are always -1, -2. So let's actually look at, I think, some of the things, like, for example, if you have any monoatomic ion, okay, this is very easy. If you have any monoatomic ion, the oxidation number follows the ion. For example, if I have F minus, okay, it's a monoatomic ion. So what is the oxidation number? -1. Follow the charge. Okay. So which one, Giuliano? The first one is -1. Where is it?
For
Giuliano?
oxygen, I think the first one is -2 divided by 2.
-2 divided by 2. Which one? You mean the H2O2?
Yep.
Yes. But it's already divided. 2 divided by 2 is what?
Hmm?
Can Juliano?
I think it's -2.
Negative. Oh, sorry. Okay, you bring over here. This is negative. So this is -1. Correct. So this one is going to be -1. Okay, -1. Okay, the rest I think is correct. So this one is going to be different number, yeah. But here, okay, let's actually continue the monoatomic ion. So if I have Cl minus, then it's also -1. O2 minus, then follow -2. So if you have P3 minus, Kevin, what is the oxidation number then? Kevin, are you with us?
-3.
Yeah, -3. So the monoatomic ion, they actually follow the charge. Okay, the same, yeah, not only negative ions. Okay, if you have Na plus, Al3 plus, okay, they follow the charge. Okay, so it's going to be +1. This one is going to be +3 and so on. Okay, so these are the example. Now, sum of oxidation number in compound. Okay, sum of oxidation number in compound is always 0. Okay, it's always 0. Like, for example, this one, just now, remember we actually put calculate for H2O2. I put like this and then I put 0. I put like this, I put 0. So it means in a compound, okay, in a compound, the sum of oxidation number of hydrogen and oxygen is going to be 0, the overall. Okay, overall. So if I have NaCl, overall is going to be 0. If I have MgCl2, overall it's going to be 0. Okay, it's in a neutral compound. Now, sum of oxidation number in ion, okay, will follow the charge. Similar like monoatomic ion. But now, if it is, let's say, for example, you have MnO4 minus. Okay, MnO4 minus. So what is the total oxidation number for this? The total oxidation number for this is following the charge, which is -1. So if I have SO4 2 minus, what is going to be my total oxidation number? This total oxidation number will follow the charge -2. PO4 3 minus, what is the oxidation number? The total is going to be for this is going to be -3. That's going to be the total oxidation number. Okay, so now if we try to look back here, okay, if we try to look back here, I want to actually ask someone here, maybe Nathan, what is going to be the oxidation number for this?
Is it +4?
No, you just no need to ignore these numbers, yeah.
Oh.
Ignore those numbers. The oxidation number is follow the charge, +2. Okay, +2. This one oxidation number is 0. Okay, how about Cu2 plus? Okay, Jasmine, what is the oxidation number?
2 plus.
Okay, it's supposed to be +2. Yeah, +2. You just need to change a bit. Yeah. The ion we say 2+, but the oxidation number is +2. Yeah. So what is going to be the oxidation number of this, Sharon?
+3.
+3. Now, remember just now I taught you about, okay, number 4. Okay, you can also determine oxidation and reduction by using oxidation number. Okay, so you see here, when this Fe2 plus change into Fe3 plus, what can you say about the oxidation number? Increase or decrease? Even?
Increase.
So if it is increase in oxidation number, what can you say? Is it oxidation or reduction? Even?
Oxidation.
Oxidation. Okay. So increase is going to be oxidation. So this is oxidation. So to be exact, what is being oxidized here? Fe2 plus is being oxidized to become Fe3 plus. Okay. So here you can see from +2 to become 0. Okay. So there is going to be decrease in oxidation number. So if there is decrease in oxidation number, this is called reduction. Okay. So what is being reduced here? Copper 2 plus is being reduced to become copper. So there are different ways to identify, not only using the electron, but even you can also use the oxidation number, okay, for half equations. I'll teach you also, quite simple. You see, just now we use the electrons, okay, but let's say you don't like to use electron. You can use oxidation number +2 to become 0. So that is going to be reduction. It's still the same thing. +2 to become +3. You can see it's going to be oxidation. Okay, please remember all this. Okay, now let's actually try some calculations first. Okay, using this this method. Yeah. So let's say I want to actually calculate MnO4. Okay, let's say KMnO4. Okay, I want to actually calculate what is going to be the oxidation number of Mn. And I want to also calculate what is going to be the oxidation number of this as well, potassium dichromate. So I want to actually calculate the oxidation number of chromium. So how to do this? Okay, I'll teach you how to do this calculation. I always do this. Okay, I think it's not compulsory, but I always do this where I separate this. Okay, when I separate this, I am going to get K plus MnO4 minus. If I separate this, I'm going to get 2K plus Cr2O7 2 minus. Okay, this is what I do. Yeah, but if you want to use, let's say the oxidation number of K is actually group 1 plus 1, you can actually do that also. Okay, I'll just show you my method first. Okay, I separate this one, so I want to calculate Mn in this. Okay, Mn in this. So what I do, okay, I want to calculate the oxidation number of Mn. I put X. So X plus 4 times what? Oxygen. Always what, Michael? Michael, oxidation number is?
2 minus.
Yeah, -2 equals to what is going to be the overall charge for this molecule or ion? Josh?
-1.
Yeah. So I can have X equals to +7. Okay. I will show you. Okay. If you calculate using KMnO4 is still the same. Okay. K is going to be group 1. So I use +1 plus I put X plus 4 times -2 equals to, what is this? What is the overall charge of this entire thing, Nathan?
The overall charge, X,
No,
X7.
no. Overall charge of oxidation number in compound is 0. So this one you don't see any charge over here. So it's going to be 0. Okay. So you put X, okay, minus 8 plus 1 minus 7 equals to 0. X equals to plus 7. You still get the same answer. Okay. So the oxidation number is going to be plus 7. What is the oxidation number? For Mn. Yeah, for Mn. Okay. So next, okay, if I want to actually calculate for Cr, okay, in this case, I'll just quickly show you Cr2O7 2 minus. Okay, if I want to calculate, this is X, that's 2. So I put 2X plus 7 times negative 2, because oxygen is always negative 2, equals to overall charge is going to be negative 2. 2x minus 14 equals to negative 2. 2x equals to negative 2 plus 14. You will get 12. X equals to 12 divided by 2. You will get plus 6. Let's say you don't want to use this method. You don't want to separate. Okay, you want to do them. You want to calculate them together. Okay, the same way. This is group 1. So 2 times plus 1 plus 2 times x plus 7 times negative 2 equals to what? Equals to 0. So you calculate 2 plus 2x minus 14 equals to 0. 2x minus 12 equals to 0. X is again plus 6. You will get the same thing. Okay. So that is going to be the way to calculate oxidation numbers. Okay. Any question up to here? Thompson?
No, sir.
Okay, so I will continue a little bit. Later we'll actually do some more calculations. Okay, but I'll continue about this naming of compounds. Okay, naming of the compound. Now, when you name compounds, okay, if I have FeO, okay, I also have Fe2O3. Okay, maybe Jeffrey. Are these two compounds the same thing?
No, sir. It's different, right?
Different. They are very different because the way they are combined, right? So is it fine to call them iron oxide and iron oxide?
No, right?
No, because they are different, right? So you have to actually come up with a name to distinguish them. Okay. How do I come up with a name to distinguish them? Okay, is by using the oxidation number. Okay. So let's actually look at the oxidation number. This is Fe2 plus and then O2 minus. This is Fe3 plus O2 minus. Okay, then I times with 3, I times with 2, then they came over here. Okay, the same thing here, they are same, so I no need to times FeO. Yeah, so if I want to find out the oxidation number of Fe, okay, Sharon, what is the oxidation number for the first one for Fe?
Fe only.
Yes.
0
No.
plus.
In this compound, not when they are alone. So in this compound, they will follow the charge, right?
Yeah.
So it's going to be plus 2. You need to put 2 there. This is called iron 2 oxide. Okay, this is called iron 2 oxide. So what is the oxidation number for the ion in this compound? This is going to be plus 3. Okay, so I will put iron 3 oxide. Okay, iron 3 oxide. So similar to that, okay, please remember the number, if they come in the middle, okay, it represents the oxidation number here on the left hand side. Okay, So like for example, if I want to actually write any example like copper, okay, copper 1 oxide. What does it mean? This copper, oxidation number of copper is +1. Oxide is always 2 minus. So if I want to write copper 1 oxide, what I need to do is I need to times this by 2 to get +2. The charges are okay. So Nicholas, you can go. So you will get Cu2O. This is copper 1 oxide. So if I want to write down for copper 2 oxide, how do I write down? Okay, so it will become Cu2 plus. Okay, follow this one. And then 2 minus. Both of them, the charges are the same. So join them together, CuO. So this is called copper 2 oxide. Can you understand this? Christopher, can you understand?
Yeah.
Now, let's actually come back to a special thing over here. I will relate this same thing with this. What is the full name for Audrey? You can go. Let's say Benedict. Can you tell me what is the full name for this compound? Potassium. Potassium what? If don't know, just tell don't know. We can actually continue. I'm still rushing for time. Benedict, can you hear me? Okay, we'll continue with Thompson. Yeah, Thompson. What is the full name for this compound?
Manganese.
Okay, potassium manganate. Okay, so this is potassium manganate, but there will be a number here. Okay, there will be a number here. So can someone give me the number that will come over there, Megan?
Sorry, sir. My mic was
Yeah.
configured to the it was configured to the wrong mic.
Okay, it's okay. It's okay, Benedict. So Megan, can you actually tell us what is going to be the number that is going to come after potassium manganate?
The IV.
Is it IV? No. Potassium manganate, they always write down V2, right? Do you know what is V11? It's actually 7. And we have calculated that 7 here. So it means the 7 shows the oxidation number of what? Manganate. Manganese. Okay. So if you want to actually write down the full name of this compound, this is potassium dichromate. Okay, Giuliano, what is going to be the number over here? Giuliano, what is the number?
6.
Yeah. V1. 6. So those numbers, okay, that you see, okay, in chemistry, that's a meaning because the 6 tells us the oxidation number of chromium, okay, the Cr, okay. So please take note, how do we actually name compounds based on the oxidation number, okay. I hope you learn a lot of things actually today, okay. I will actually discuss more on how to use, okay, oxidation number for calculation, how to balance equation and so on. This is going to be just the introduction, okay, for redox reaction. So I think the basic calculations and things that you need to know and how do we name them, okay, it is important. So can someone quickly summarize? I need to actually go to another class already. Maybe Jasmine, can you summarize what you have learned today?
We learned about oxidation and reduction and how to determine if an equation is oxidized or reduced.
Okay. What else?
We learned about how to find the oxidation numbers for a compound.
Okay. How about half equation?
We learned that half equations can be used to balance ionic equations.
Yes. And I think this one you mentioned just now. And then the last one.
We learned that oxidation numbers are like the numbers in the bracket.
Yeah, the numbers, the oxidation numbers can be used when you name the compound to differentiate the compound. Yeah. So that is actually one of the use of the oxidation number. Okay. I hope you understand this. Those who wants to go to toilet, you can go. Okay. Anyway, thank you guys. Okay. If you have any question, just ask me in the WhatsApp. Yeah. Okay. See you guys. Bye.
Bye, sir.
Bye, sir.
Yes, sir.
Good luck for your test later.
Sir.